Morning students, in this section we are discussing about categories of solids, and the categories of solids are three. They have been categorized based on their conducting properties. The solids are three categories and they are categorized based on their conducting properties. The first one is conductor and the second one is semiconductor, then followed by third one is insulator. So the conductors are substances. Conductor are substances which easily allows electrons to pass through them. Right? Which easily allows electrons to pass through them. So let us learn about what conductors totally are all about. So in conductors there is no forbidden energy gap. So we can see here there is no forbidden energy gap. I will draw one more diagram regarding conductors here. So this is valence band and this is conduction band. This is what this is, this area. So what happens in conductors? The valence band and conduction bands are overlap with each other. Means what? They reside one on. That's why there is no energy gap. Then only the electrons easily go from valence band to conduction band because there is no energy gap. So the valence band and the conduction band overlap. Next, the electrons from valence band freely enter into the conduction band because of there is no energy gap and the overlap of conduction band and valence band. Fine. So what are conductors? First of all, understand what are conductors. Conductors are those substances which easily allow the electrons to pass through them. That's why they are conductors. Fine. Example for conductors you can think like copper. That's why they are used in electrical wires so that the current easily pass through the copper, aluminium. Fine. So when you open your electrical wires, you will find copper inside it. So that is the best conductor of electricity. That's why they have used. Fine. So conductors are those substances which easily allows. So it is because why the conductors easily allow electrons to pass through them is because they don't have any forbidden energy gap. I mean to say the valence band and conduction band are overlapped with each other. Right? Therefore, very low potential difference can cause continuous flow of current. What happens if very low input voltage is given to a conductor? The electrons will get enough kinetic energy to easily pass through it. Fine. So let us learn about what are the different properties what a conductor has. So a conductor is a material having zero energy gap. Means what? There is no energy gap. The materials in which conduction and valence bands. What? If a material has a zero energy gap, it means what? The valence and conduction bands are overlapping each other. Valence electrons can move to conduction band without requiring any thermal energy, or I mean to say any external energy. So even at normal room temperatures, some of the electrons or more of the some of the electrons will get enough energy to detach from the outer orbit, that is from valence band, and jump into the conduction band. The overlapping indicates what is overlapping here? The overlapping of conduction band and valence band indicates a large number of electrons available for conduction. Means what? When it overlaps, there are available large number of free electrons. Those free electrons are responsible for conduction of current. Fine. Hence, the application of a small amount of voltage results large amount of current. So if you apply a small amount of voltage to the conductors, it gives you large amount of current. What happens when small voltage is given to a conductor? There is an availability of large number of free electrons. Those free electrons will cross the valence band, then enter into the conduction band, constituting electric current. And so example, all metals. All metals. The best conducting materials are silver, copper. So let me write here: silver, copper, aluminium, etc. Right? So these are the best example of conductors, and we use these materials in our home appliances, like switches, electrical wires. We use all these things. So then comes next the semiconductors. So conductors are the materials which allows electrons to pass through them very easily. So what happens in semiconductors? So semiconductors are those substances whose electrical conductivity lies between insulator and conductors. Let me see here. In case of semiconductors, the forbidden energy gap is very small. So there will be an energy gap, but that energy gap is very small. Right? So at the OK conditions are perfect conditions, the conduction band is empty and the valence band is completely filled. I mean to say that at OK condition, the valence band is completely filled with electrons, whereas conduction band is completely empty. Fine. When a small amount of energy is applied to the electrons, when a small amount of energy is applied to an electron, the electrons can easily jump into the conduction band, crossing this forbidden energy gap. So the conductivity of a semiconductor is of the order 10 raised to 2 milliohms per meter. Fine. So the conductivity of semiconductors depends upon the energy gap. How much energy gap is there between conduction band and valence band? In some other words, we can also say semiconductors energy gap is between conductors and insulators. And so the materials in which the conduction and valence bands are separated by a small amount of energy gap, as I have told, that is 1 electron volt, are called as semiconductors. Silicon and germanium are the most perfect and most commonly used semiconductor. Silicon and germanium are most commonly used semiconductors. So when a small amount of energy is given, I mean to say energy is given to the electrons which are there in valence band, which is written here. A small energy gap means that a small amount of energy is required to free the electrons which are there in valence band. So when that energy is being given to the electrons which are there in valence band, they will get enough energy and they move into the or they jump into the conduction band to constitute electric current. If the temperature is further increased, more number of valence electrons will acquire energy and jump into the conduction band to constitute electric current. The next comes, if a valence electron receives sufficient thermal energy, it can move into the conduction band, leaving a vacancy in the valence band. So whenever electron jumps from valence band to conduction band, so that electron after jumping it leaves a hole there, which leaves a hole there. So therefore, if one electron jumps from valence band to conduction band, one hole is created, and it is called as hole current. Fine. So carrier generation can happen due to the thermal excitation. I mean to say, how we can make an electron to jump from valence band to conduction. What are the different methods? First one is thermal excitation, then photo excitation, electrical excitation, impact ionization. So these are the four methods which are available to make an electron to jump from valence band to conduction band in semiconductors. Fine. So now comes the last part, that is insulators. So insulators, what is an insulator first of all? Insulators are the substances which does not allow electrons to pass through them. Fine. So as I have written the definition, what is semiconductor? Semiconductor is a device or it is a substance which allows electrons to pass through them, whereas insulator does not allow any electrons to pass through them. For example, if you take wood or if you take glass, rubber, these are the perfect examples of insulators, where they don't allow any electrons to pass through them. So when the temperature is increased, then some electrons will go to the conduction band. This is the reason why certain materials which are insulators at room temperature becomes conductors at high temperature. Fine. We still worried about this one. If I take an example of wood or plastic, so it is a perfect example of an insulators where the energy gap between this conduction and valence band is very large. So to cross an electron from valence band to conduction band, it requires very high energy. So that energy can be gained from, I mean to say, increasing temperature. So some of the insulators at room temperature, they may act as insulators. As the temperature increases, they will act as a conductors. Then as the temperature increases, these electrons will get enough kinetic energy and they will jump into the conduction band to constitute electric current. In terms of energy band, valence band is completely filled with electrons, whereas conduction band is totally empty. The electrical conductivity of insulator is very small in ordinary conditions. So at room temp or at some, as the temperature increases, some of the electrons will get enough energy crossing. Then they will act like a semiconductor or conductor. Right? So these are the comparison between insulators, conductors and semiconductors. So again I will go through it. Let us check. This is valence band and this is conduction band, and the energy gap is very large, very large compared to the semiconductors. Here the energy gap is very small. So this energy gap can be overcome by applying some energy, external energy, so that the electrons can cross orbital energy gap and get it into the conduction band. Whereas you come to the conductors, this is what overlapping of conduction band and valence band. Fine. So these are the comparison of insulators, semiconductors and conductors in terms of energy bands. Next. So in terms of resistivity versus temperature regarding conductors and semiconductors and insulators. So as temperature increases, the conductivity increases. Whereas in low temperature, the conductivity will increase but less amount of conductivity. Whereas in semiconductors, temperature increases, the resistivity decreases. As temperature is on the x-axis, resistivity is on the y-axis. As the temperature increases, the resistivity decreases. What happens when temperature increases? More number of electrons which are there in the valence band will get enough kinetic energy and they jump into the conduction band. Then automatically the resistivity of semiconductor decreases. Both are inversely proportional. That is, temperature and resistivity in semiconductors are inversely proportional. Fine. So these are the examples of semiconducting materials which are available. So carbon and their respective energy gap in terms of electron volts. So carbon, silicon, germanium, tin, gallium, indium, silicon, cadmium, then boron, aluminium, gallium, indium nitride and gallium nitride, aluminum nitride, boron nitride, and these are all some of the examples of semiconductor materials and their respective energy gap. So we can see that which is having very less energy gap. I mean to say tin has very less energy gap, whereas germanium also has less energy gap, which is most widely used, germanium. Then silicon is also widely used as a semiconductor, which is also less energy gap. Right? Thank you.